What if our planet is already home to creations so unseen, so unreal, they feel almost impossible in the age of limits we think we know? Shock begins high in the misty mountains of central Vietnam, where the Golden Bridge appears to float above the forest, held aloft by colossal stone hands. A structure less like a crossing and more like a vision, blurring the line between landscape and imagination. It echoes across the Nevada desert in the United States, where the Sphere in Las Vegas risen as the largest spherical structure ever built. Wrapped in millions of LEDs, it transforms architecture into a living surface, capable of turning light, data, and motion into an entirely new form of spectacle. And the scale intensifies in China, where the Siduhe Bridge stretches across a deep karst canyon. Suspended hundreds of meters above the void, it ranks among the highest bridges on Earth, a razor-thin thread of steel defying gravity, distance, and fear itself. These are mega projects that challenge physics, geography, and the edges of our collective imagination. In the moments ahead, you'll step into mountains, cities, and extreme frontiers where humanity is quietly rewriting what can and cannot be built. The blueprint of the impossible is expanding, and the next boundary may be closer than anyone expects. What you're about to see may change how you view the world we think we already understand. Wuhan Skyrail. As cities grow denser and space on the ground disappears, a question begins to rise above the skyline. How do modern cities keep moving when streets are already full and the underground is exhausted? In central China, one answer arrives not on the road or beneath it, but in the open air itself. Suspended more than 30 feet above the ground, an elevated single-rail system glides across rivers, rooftops, and traffic, carving out a new layer of urban movement. Instead of expanding outward or digging deeper, engineers chose to build upward, transforming unused sky into working infrastructure. The trains operate without drivers, guided by automation, sensors, and artificial intelligence that maintain balance and spacing with precise control. Each carriage is designed with expansive glass windows that extend down toward the floor, with select sections using transparent panels that allow passengers to look directly below at streets, rivers, and parks sliding past beneath their feet. Lightweight carriages reduce structural stress and cut energy consumption to nearly half that of traditional subway networks, while noise levels remain low enough to blend into daily life. On test sections stretching roughly 6 miles, trains approach speeds of 50 miles per hour, proving that elevated transit can rival underground systems. With fewer support columns and modular construction, build times can shrink to just 2 years, reducing cost and disruption in crowded districts. This is more than a train line. It is an experiment in three-dimensional mobility where science, geography, and urban history converge to redefine how cities move through space. Golden Bridge. High above the forests of central Vietnam, a question quietly takes shape in the clouds. What happens when architecture stops competing with nature and begins to collaborate with it? At an elevation of nearly 4,600 feet above sea level, a pedestrian bridge curves gently through mist and shifting mountain air, appearing less built than imagined. Stretching approximately 528 feet in length, the structure seems to float between ridgelines, supported by two colossal stone hands that resemble ancient guardians rising from the earth. Though they appear weathered by centuries, the hands conceal a modern steel framework beneath textured surfaces, blending advanced engineering with the illusion of deep time. Rapid changes in temperature and humidity cause clouds to roll in without warning, often enveloping the walkway in dense fog and producing the sensation of walking through open sky. Shortly after its unveiling, images of the bridge spread across global media, appearing in major international publications and becoming one of the most shared architectural landmarks on Earth. More than a destination, the Golden Bridge represents a new chapter in how Vietnam merges landscape, history, and engineering into a mega-project that feels both ancient and unmistakably futuristic. Museum of the Future. Rising along Dubai's skyline, this structure appears not as a monument to history, but as a question mark shaped from steel and light. Its hollow, circular form symbolizes a future still unwritten, with a central void representing what humanity has yet to become. The exterior is wrapped in flowing Arabic calligraphy, enlarged to architectural scale, where words double as windows, filtering daylight through philosophy and language. Behind the skin, the building relies on a radically curved steel framework, engineered through advanced digital simulation and assembled with robotic precision, allowing the structure to stand with almost no traditional support columns. Every metal panel on the facade is unique in shape and curvature, numbering more than 1,000 individual pieces, making it one of the most complex architectural surfaces ever constructed. Inside, the museum abandons the past entirely. Visitors move through immersive environments that explore artificial intelligence, space travel, and bioengineering, including a simulated orbital station set in the year 2071, imagining daily life beyond Earth. Another zone focuses on planetary ecology, examining biodiversity, climate repair, and the science of restoring life systems on a global scale. Rather than showcasing finished inventions, the museum presents evolving ideas and speculative technologies already influencing the world today. At roughly 250,000 square feet, the structure functions as both exhibition space and experimental laboratory. More than a building, it is a scientific narrative, using architecture itself to explore how design, technology, and human imagination may shape the centuries ahead. Siduhe Bridge in China rises in the mountains of central China, where sheer cliffs collapse into narrow canyons and clouds drift like living terrain. Suspended more than 1,600 feet above the valley floor, the bridge stands so high that mist can pass beneath its deck, turning gravity itself into part of the landscape. When it opened, it briefly held the title of the highest bridge on Earth, spanning a gorge so deep and narrow that conventional construction methods were impossible. Engineers worked under relentless wind and dense fog, with visibility often vanishing for days at a time at such extreme elevation. With no access roads to the canyon below, steel and concrete were transported by cable systems stretching several miles across open air, converting the void into a temporary construction corridor. The bridge permanently reshaped regional mobility. Journeys that once required multiple hours along dangerous mountain roads were reduced to just a few minutes, reconnecting isolated communities and trade routes. More than a crossing, Siduhe Bridge proves that modern engineering can suspend an entire transportation lifeline between Earth and sky. Channel Tunnel. Beneath one of the busiest seas on Earth, a quiet question once challenged engineers and geologists alike. Could two nations be connected not by ships or skies, but through solid rock beneath the ocean itself? Deep below the English Channel, an underground corridor stretches for nearly 31 miles, forming a hidden link between the United Kingdom and France. More than 23 miles of this passage lies entirely beneath the seabed, with its deepest point reaching roughly 250 feet below sea level, where pressure, water, and geology leave no margin for error. The system is composed of 3 parallel tunnels, 2 carrying high-speed trains in opposite directions, and a central service tunnel designed for maintenance, ventilation, and emergency access. Trains race through the darkness at speeds exceeding 160 miles per hour, compressing the journey between London and Paris to just 2 hours. Massive tunnel boring machines advance simultaneously from both coastlines, navigating through layers of chalk marl, and when they met beneath the sea, the alignment error measured only a few inches, an extraordinary achievement in the era before modern GPS. Construction continued non-stop for nearly 6 years, involving more than 13,000 workers operating across borders, languages, and engineering traditions. The tunnel does not carry cars driven by passengers, but entire vehicles loaded onto specialized trains, redefining how land transport moves across water. More than infrastructure, the Channel Tunnel stands as a triumph of geology, mathematics, and international cooperation, proving that even oceans can be crossed without ever seeing the surface. The sphere. Rising from the neon desert of Nevada, this colossal sphere signals a radical shift in how humans experience entertainment, science, and technology. Towering at roughly 366 feet tall and separating 516 feet wide, it stands as the largest spherical structure ever built for public performance. Its exterior is wrapped in more than 1 million programmable LED lights, transforming the building into a living screen visible from several miles across the Las Vegas Strip, capable of displaying moving images, data patterns, and even planetary surfaces. Inside, audiences are surrounded by a seamless curved display with a resolution exceeding 16K, creating the illusion of standing inside oceans, outer space, or microscopic worlds. Sound travels just as precisely. A beam-forming audio system uses thousands of speakers to direct sound to individual seating zones, allowing different areas to hear entirely different audio at the same time. Engineered to withstand desert heat, wind, and vibration, the structure relies on advanced materials science and computational modeling to maintain acoustic and visual perfection at scale. Designed for concerts, cinema, scientific visualization, and immersive education, this is not simply a venue. It is a technological environment where architecture, physics, and digital storytelling converge to redefine what entertainment can become in the 21st century. Delta Works. Along the low-lying edge of Europe, where land and sea constantly negotiate their boundaries, one nation chose engineering over retreat. Born from the devastation of the 1953 North Sea flood, this vast flood defense system was designed to protect a country where nearly 1/3 of the land lies below sea level. Instead of building a single wall, engineers created a living network of dams, storm surge barriers, and movable gates stretching more than 100 miles across river mouths and coastlines. Some of the largest barriers can swing shut in just a few minutes when storm surges approach, sealing off the sea, yet remain open under normal conditions to preserve shipping routes and tidal ecosystems. At its core, the system represents a marriage of geology, hydrodynamics, and long-term climate science, accounting for tides, sediment movement, and rising sea levels decades in advance. Rather than fighting the ocean outright, the design allows water to move, breathe, and flow under controlled conditions. More than infrastructure, the Delta works stand as a modern wonder, proving that humanity can coexist with the sea through foresight, precision, and respect for natural forces. International Space Station, ISS, drifts silently above Earth as the largest structure ever assembled by humans beyond the atmosphere. Orbiting at an altitude of roughly 400 kilometers, this floating laboratory completes a full circuit of the planet in about 90 minutes, moving fast enough to witness the sunrise and sunset as many as 16 times every day. From this vantage point, the station travels at nearly 17,000 miles per hour, balancing between gravity and freefall in a continuous state of microgravity. Inside, astronauts conduct thousands of experiments impossible on Earth, studying how the human body adapts without weight, how flames behave without convection, and how new materials form in near-perfect conditions. The station's modular design, spanning more than 350 feet from end to end, was assembled piece by piece in orbit, requiring dozens of spacewalks and years of coordination. More than a laboratory, it is a symbol of exploration, proving that humanity's most ambitious projects do not always rise from the ground, but can circle the planet itself. Palm Jumeirah. Off the coast of Dubai, a new shoreline was not discovered by chance, but deliberately engineered as Palm Jumeirah emerged from the Persian Gulf in the shape of a colossal palm, large enough to be clearly visible from space and bold enough to redefine how humans interact with the sea. The island was created using more than hundreds of millions of tons of sand and rock, precisely dredged from the seabed and positioned without concrete, allowing natural forces like gravity and wave motion to stabilize the structure over time. Its palm-shaped design was not purely symbolic, as the trunk and fronds expanded Dubai's usable coastline by dozens of kilometers, creating room for residential districts, luxury resorts, and critical infrastructure where open water once dominated. Surrounding the island is a massive crescent-shaped breakwater stretching several kilometers, engineered to absorb wave energy, reduce erosion, and shield the inner shoreline from powerful storms. The project required advanced modeling of ocean currents, sediment behavior, and long-term coastal dynamics, blending geology, marine science, and satellite-guided construction. More than an expression of wealth, Palm Jumeirah marked a turning point in human history, demonstrating that entire islands could be designed, shaped, and placed with intention, effectively allowing humanity to redraw the map itself. Port of Shanghai, China, stands at the mouth of the Yangtze River, where inland waterways merge with the open sea, operating as the beating heart of global maritime trade and moving goods at a scale few places on Earth can match. Each year, this vast port system handles more than 40 million containers, a volume that surpasses any other port worldwide and reflects China's central role in modern supply chains. To overcome shallow coastal waters, engineers extended the port far offshore by constructing the Yangshan Deepwater Port and linking it to the mainland with a sea bridge stretching over 20 miles across open water. Within this offshore complex, automation redefines port operations as massive cranes and driverless transport vehicles load and move containers with minimal human intervention, guided by algorithms, sensors, and real-time data. This advanced level of automation allows terminals to operate 24 hours a day with extraordinary precision, reducing delays and maximizing efficiency in one of the busiest shipping corridors on the planet. More than a harbor, the Port of Shanghai stands as a symbol of economic gravity, demonstrating how infrastructure, scale, and automation can anchor global trade to a single stretch of coastline. Burj Khalifa in the United Arab Emirates rises from the desert of Dubai like a steel needle aimed at the sky, redefining how high a city can climb. Reaching an astonishing height of 2,717 feet, it remains the tallest building ever constructed, pushing architecture into territory once reserved for aircraft and satellites. Its stepped, tapering form is not decorative but scientific, engineered to disrupt wind vortices and reduce lateral forces that intensify at extreme altitude. Inside, the tower functions as a vertical city, housing residences, offices, hotels, and observation decks, stacked through more than 160 floors. Moving through this height required elevator systems capable of traveling some of the longest, uninterrupted vertical distances on Earth, operating under immense pressure and precision constraints. At the upper observation levels, visibility can extend dozens of kilometers on clear days, revealing how geography flattens when viewed from such elevation. The structure demanded innovations in concrete chemistry, pumping material upward to heights never attempted before. More than a skyscraper, Burj Khalifa stands as a global symbol of ambition, where physics, engineering, and urban vision converge to prove how far human construction can rise when limits are reimagined. Milo Viaduct in France stretches across the Tarn River Valley like a ribbon of steel suspended in open air, redefining both scale and elegance in modern bridge design. Rising to a structural height of more than 1,100 feet, its tallest piers stand higher than the Eiffel Tower, placing sections of the roadway among drifting clouds during foggy mornings. Built at extreme elevation, the bridge was engineered to withstand powerful winds, with a remarkably slender deck designed to minimize air resistance while maintaining stability. Every segment of the structure was assembled with extraordinary precision, despite construction taking place hundreds of feet above the valley floor, where even minor misalignment could become catastrophic. Geology played a crucial role, as engineers analyzed the limestone plateau beneath the piers to anchor the bridge securely without disrupting the fragile landscape. Completed in just 3 years, the viaduct transformed regional travel by allowing vehicles to cross the valley in minutes rather than winding through mountain roads for hours. More than a solution to traffic, the Millau Viaduct is widely regarded as a masterpiece of engineering, proving that infrastructure can function as both scientific achievement and floating work of art. Shanghai Tower rises from the heart of China's largest city as a twisting column of steel and glass, engineered not only to reach the sky, but to negotiate with it. Soaring to a height of 2,073 feet, the tower ranks among the tallest buildings ever constructed. Yet its defining feature is not height alone, but motion, as its subtle spiral form reduces wind loads by nearly 24%, a critical advantage in a city shaped by typhoons. Inside, the structure functions as a vertical city, built around a building within a building concept that creates multiple climate-controlled zones, improving energy efficiency while enhancing safety at extreme elevations. These layered spaces act as thermal buffers, lowering energy consumption and allowing natural light to penetrate deep into the interior. Movement through the tower is powered by some of the fastest elevators on Earth, reaching speeds of over 40 miles per hour, carrying occupants hundreds of floors upward in under a minute. Advanced damping systems, sustainable materials, and intelligent monitoring technologies work together to keep the structure stable, efficient, and resilient. More than a skyscraper, Shanghai Tower represents a fusion of physics, environmental science, and urban ambition, standing as a symbol of how future megacities may rise higher while treading more lightly on the planet. Jiaozhou Bay Bridge in China stretches across open water on a scale that redefines coastal infrastructure, linking the city of Qingdao with surrounding districts in a single sweeping line above the sea. Extending for more than 26 miles, it ranks among the longest sea-crossing bridges ever built, traversing a bay where tides, winds, and weather patterns shift constantly. To survive this environment, engineers designed thousands of reinforced concrete piers anchored deep into the seabed, each built to resist corrosion from salt water over decades of exposure. The bridge's geometry was carefully calculated to distribute loads evenly, while allowing for thermal expansion, wave impact, and seismic movement beneath the structure. Before its completion, vehicles were forced to travel long, winding routes around the bay, turning short distances into journeys lasting hours. The bridge compressed those trips into minutes, reshaping daily life, logistics, and regional development. Construction demanded precise marine engineering, from underwater foundation work to continuous monitoring of currents and sediment movement. More than a transportation shortcut, Jiaozhou Bay Bridge stands as a symbol of China's ability to extend large-scale infrastructure into the marine environment, transforming geography through engineering vision. Hoover Dam. Rising from the Black Canyon of the Colorado River, this massive structure stands as a monument to 20th century engineering, built in one of the harshest desert environments in North America. Completed during the era of the Great Depression, the dam transformed a volatile river into a controlled source of water and power, delivering electricity to millions of people across several western states. At the time of construction, it was considered a technical marvel, containing more than 4 million cubic yards of concrete, enough material to pave hundreds of miles of roadway. That volume created an unexpected scientific challenge, as curing concrete generates heat, and without intervention, the dam would have taken more than 100 years to cool naturally. Engineers solved the problem by embedding an intricate network of cooling pipes, circulating cold water to stabilize the structure from the inside out. Behind the dam, Lake Mead formed and became the largest man-made reservoir in the United States for decades, reshaping the geography and climate of the surrounding region. Constructed in just 5 years, the project provided jobs for thousands of workers at a moment when employment meant survival. More than a dam, Hoover stands as a symbol of human ambition, proving that engineering, science, and collective effort could tame nature on an unprecedented scale. Panama Canal. Cut through the narrow waste of Central America, the Panama Canal stands as one of the most influential engineering achievements in human history, quietly reshaping how the planet moves goods. Stretching roughly 50 miles from ocean to ocean, the canal allows ships to avoid a journey of more than 8,000 miles around the southern tip of South America, saving weeks of travel and vast amounts of fuel. Instead of carving a channel at sea level, engineers devised a gravity-powered lock system that lifts vessels nearly 85 feet above sea level before lowering them back down on the opposite side. This design turned water itself into a machine, using massive freshwater chambers to raise ships weighing tens of thousands of tons with remarkable precision. Construction in the early 20th century was as much a medical battle as an engineering one, as breakthroughs in controlling yellow fever and malaria saved thousands of lives and made large-scale work in the tropics possible. Each year, more than 14,000 vessels pass through the canal, carrying roughly 6% of global maritime trade. More than a shortcut, the canal permanently altered geography, economics, and geopolitics, proving that science and persistence could redraw the map of the world. Marina Bay Sands rises from reclaimed land along the city's waterfront as a bold experiment in how engineering, geography, and ambition can reshape an urban skyline. The complex is defined by three slender towers, unified at the top by a sky park positioned nearly 200 meters above ground, a height where wind pressure and thermal expansion become real engineering constraints rather than abstract equations. Resting above the towers, the structure supports an infinity pool stretching more than 1 football field in length, holding thousands of tons of water while allowing subtle movement so each tower can sway independently without transferring dangerous stress. Inside, the development functions as a vertical city, containing over 2,500 hotel rooms, exhibition halls, theaters, retail zones, and a museum designed to merge architecture with science and public learning. Construction demanded extreme precision, as the Sky Park was assembled in massive sections and lifted into place with tolerances measured in millimeters. More than a luxury landmark, Marina Bay Sands stands as a living laboratory, proving that modern engineering can balance scale, stability, and spectacle in a dense urban environment. Baihetan Hydropower Station stands deep within a dramatic canyon carved by the Jinsha River, where geology, water pressure, and gravity collide at an extreme scale. Anchored between steep rock walls, the dam rises to a height of more than 280 meters, making it one of the tallest concrete arch dams ever constructed, while withstanding immense horizontal forces generated by a massive reservoir upstream. Inside the powerhouse, each turbine is a technological giant, capable of generating over 1 gigawatt of electricity, a level once thought unreachable for a single hydropower unit, allowing the station to produce a total output exceeding 16 gigawatts. To achieve this, engineers developed advanced materials and cooling systems to control heat, vibration, and microscopic cracking within the concrete structure. Built in a region prone to seismic activity, the dam incorporates real-time monitoring sensors that track stress, movement, and water pressure every second of the day. More than a power plant, Baihetan represents a turning point in hydro engineering, where science, geography, and scale merge to redefine how rivers can be harnessed in the modern era. Gardens by the Bay rises along the waterfront as a vision of urban ecology, blending nature and technology in ways previously unseen. Towering above the landscape, the super trees reach heights of up to 16 stories, functioning not only as striking vertical gardens, but also as energy collectors, harvesting solar power and channeling air for natural ventilation. Inside the massive conservatories, climates from across the globe are recreated with precision, from Mediterranean warmth to tropical cloud forests, covering a total area of more than 250,000 square meters. Rainwater is captured, recycled, and used throughout the park, while photovoltaic panels provide a significant portion of the energy needed to sustain the green environment. Visitors traverse elevated walkways stretching over 1,000 feet among the super trees, experiencing the convergence of architecture, biology, and environmental engineering in a living laboratory. More than a park, Gardens by the Bay is a manifesto for the future of urban green space, proving that cities can harmonize aesthetics, climate management, and biodiversity on a monumental scale. K2O Power Station rises across the plains of Inner Mongolia as one of the world's largest coal-fired power plants, producing a staggering total output exceeding 6,000 megawatts, enough to supply millions of homes and industrial centers across northern China. The station uses advanced combustion technology to maximize efficiency while reducing emissions, paired with a modern ash handling system that captures byproducts before they pollute the environment. Operating in extreme temperatures, turbines and boilers are continuously monitored with sensors and automated controls, ensuring uninterrupted power delivery even under harsh conditions. Miles of conveyors, cooling towers, and emission controls illustrate the engineering scale required to transform coal into reliable electricity at this magnitude. More than a power plant, K2O is a testament to human ingenuity, combining industrial engineering, environmental management, and energy science to meet the demands of a vast region. Hudson Yards rises along the Hudson River in Manhattan as one of the most ambitious urban redevelopment projects in recent decades, reshaping the skyline with a carefully orchestrated mix of towers, public spaces, and infrastructure. Built on the former industrial rail yards, the development rests atop a platform supported by more than 20,000 steel piles and reinforced beams capable of bearing immense loads, creating a foundation strong enough for multiple skyscrapers. The complex contains office space, luxury residences, hotels, and retail areas covering over 12 million square feet, integrated with parks and pedestrian zones that reconnect the city to the waterfront. At its heart, The vessel's sculpture spirals upward over 150 feet, with 2,000 interconnecting steps, serving as both a public landmark and a symbol of vertical exploration within an urban environment. More than a development, Hudson Yards exemplifies how modern cities can balance density, design, and sustainability, creating spaces that are functional, iconic, and seamlessly integrated into the urban fabric. Öresund Bridge stretches across the Öresund Strait as one of Europe's most remarkable engineering achievements, seamlessly combining a bridge and an undersea tunnel to connect two nations. Spanning more than 7 miles, the structure carries both road and rail traffic, reducing travel between Copenhagen and Malmö to just 35 minutes, a dramatic shortcut compared to the longer maritime route. The design integrates a cable-stayed bridge section with towering pylons over 300 feet high and a 4-kilometer undersea tunnel that allows uninterrupted shipping traffic through one of Europe's busiest waterways. Precision engineering was essential, as the bridge had to withstand strong winds, shifting seabeds, and the corrosive effects of saltwater while maintaining stability for trains moving at over 100 miles per hour. More than a passageway, Öresund Bridge exemplifies how technical mastery, geography, and international cooperation can reshape connections, fostering economic exchange and cultural ties between neighboring countries. Lacta Center rises from the heart of St. Petersburg as Europe's tallest skyscraper, piercing the skyline with a spire reaching over 1,700 feet. Its twisting design reduces wind load while giving the tower an elegant, futuristic silhouette visible across the city and the Gulf of Finland. Inside, the complex combines office spaces, public areas, scientific centers, and observation decks, all integrated into a single structure that spans more than 2 million square feet. High-speed elevators ascend the central steel and glass core at over 20 feet per second, allowing occupants to move safely and efficiently despite the extreme height. More than a commercial tower, Lacta Center exemplifies modern architectural ambition, merging engineering precision, urban planning, and technological innovation into a singular vertical landmark. Lotte World Tower soars above Seoul as the fifth tallest building in the world, reaching an astonishing height of 555 meters and redefining the city's skyline. Its tapered design reduces wind forces, enhancing stability for the ultra-tall structure while giving it a sleek, elegant profile visible from miles around. Inside, the tower houses luxury residences, offices, a hotel, and observation decks that offer panoramic views of the Han River and the sprawling metropolis below, covering a total area of over 2 million square meters. High-speed elevators propel visitors to the top in less than 60 seconds, demonstrating advanced engineering and vertical transportation technology. More than a building, Lotte World Tower embodies ambition, technological mastery, and architectural innovation, standing as a symbol of South Korea's vision for modern urban development and engineering excellence.